So these notes are on solving one variable absolute value inequalities. And just like in the last two sets of notes on the introduction to absolute value and in solving one variable absolute value equations, we have two definitions. Our first is that the absolute value of A means the distance from A to 0. And we're going to look at two examples. So we're going to say, what does the absolute value of x plus 5 less than 3 mean? So it means that the distance less than 3 units from negative 5. So the problem starts off very similarly to the problems we've seen with equations, with equalities. We start at negative 5 and we go 3 units to the right and 3 units to the left. The catch is this time that I'm not exactly 3 units, I'm actually less than 3 units. So less than 3 would be 1 unit, 2 units, 2.5, 2.6, 2.9. So that means that with an inequality, I have a whole set of numbers that make it true. In this case, I have the whole set in the middle here because these are units that are smaller than 3 units from negative 5. The other thing I have to worry about with inequalities is whether or not to include the 3. In this case, 3 is not included, and we signified that by using open circles at the boundary points of negative 8 and negative 2. And I can write my answer in two ways. I can write it in set notation, so x such that negative 8 is less than x is less than negative 2. Or I can write it in interval notation, in which case I have the boundary points of negative 8 and 2. But because this is less than, there's no or equal to, I use parentheses. Our second example is, what does the absolute value of x plus 5 greater than or equal to 3 mean? So in this case, we're looking at the distance greater than or equal to 3 units from negative 5. Again, remember that we're talking about this whole idea of starting at 0. What would x have to equal to have this be 0? It would have to be negative 5. So that's why we start from negative 5. So again, I have my number line. I have my negative 5. I go 3 units, 1, 2, 3, to the right, to the left. But now I have to ask myself, greater than 3. So if this was 3, then greater than 3 would be 4, 5, 6, 7, etc. And so I color on the outside. And the same is true going the other direction. Now, this or equal to piece means that I include negative 8, where up here in this first example, I didn't include negative 8 or negative 2. And we signify including by having a closed circle at my boundary. So now I write my answer in set notation. X is less than or equal to negative 8. Or x is greater than or equal to negative 2. And then in interval notation, I read from left to right, so negative infinity to negative 8, and it's a bracket because it's a closed circle, it includes. I use this fancy U to say that I have 2 pieces of my answer. And then the second piece is going from negative 2 to positive infinity. Now, my second definition, if you remember, says that the absolute value of A equals positive A when A is greater than or equal to 0, and the absolute value of A equals negative A when A is less than 0. So if I look at my first example, solve the absolute value of x plus 5 is less than 3. Either this part is positive and it stays positive, or this is negative, smaller than 0, and I have to change the sign. So I either have the option of x plus 5 is less than 3, or I have the negative of x plus 5 is less than 3. I'm going to solve these. I'm going to subtract 5 on both sides. I get x is less than negative 2. Here I'm going to divide both sides by negative 1. And remember that when we do that, we have to flip the inequality. Subtract 5 on both sides. Get x is greater than negative 8. Now I have two pieces here, but in the end, I know that because I'm a less than distance, that I'm actually in the middle of these two. So I can then write this answer as set notation, x such that x is less than, negative 8 is less than x is less than negative 2. Or I can write it in interval notation from negative 8 to negative 2. Now, I'm going to do this problem, I'm going to do a second example here. In which we're going to solve the absolute value of x plus 5 is greater than or equal to 3. And again, I'm going to use the exact same process that I used above. So either x plus 5 is positive, or x plus 5 is negative. And we solve. Subtract 5 on both sides. X is greater than or equal to negative 2. Divide both sides by negative 1. So x plus 5 is greater than or equal to negative 3. Subtract 5 on both sides. X is greater than or equal to, oh, I made a mistake. Do you see where I made my mistake? Remember, when I divide both sides by a negative number, I have to flip my inequality. So I have x less than or equal to negative 8. Now remember, when I have a greater than distance, I'm on the outside. So when I write my answers in set notation, I have two answers. I have x is less than or equal to negative 8, or x is greater than or equal to negative 2. And the same thing for my for my interval notation. From negative infinity to negative 8, from negative 2 to positive infinity. Again, remember the most common mistake to make here, and the mistake that I did make was to forget to flip my inequality. Dividing by a negative 1 means that the inequality needs to flip to the other side.